Let's see the next topic in general science, and that is gravitational force. And in today's session, we are going to see 10 to 15 questions related to gravitational force. Okay. So the first, we will see the important topic from this particular chapter. So in this particular chapter, these are the important topics in reference to the general science. Okay, so you should know what exactly is a gravitational force. Okay, and more specifically to the Newton's universal law of gravitation. Then you should know about acceleration due to gravity, the difference between mass and weight, free fall, weightlessness, and few of the numericals related to the gravitation. Okay, so let's see the first question. So the question says the known forces of nature can be divided into 4 classes: gravity, magnetism force, weak nuclear force, and strong nuclear force. With reference to them, which one of the following is not correct? Okay, gravity is strongest of the 4. No, student, remember, gravity is the weakest force which is found in the nature. Okay, and the strongest force is the nuclear force because it binds the atoms together or the nucleons together. Okay, so the answer for this question is option A. And we have already seen in our theory classes that there are basically 4 types of fundamental forces: gravitation, which basically acts between the masses, and this is the weakest force and it is always attractive. Okay, and the other fundamental forces include electromagnetic forces, which basically act between the charges. It can be attractive or repulsive. Whereas weak nuclear, like subatomic particles in the radioactivity case. The next one is a strong nuclear, which happens in the nucleon, that is neutron and proton. That is the strongest force which is found in the nature. Okay, so remember, gravitation is the weakest force of all the forces which are found in the nature. Okay, let's see the next question. Who among the following anticipated Newton by declaring all the things that gravitate to the earth? Okay, all things gravitate to the earth. Okay, so this is a very good question. Like all of us been studying in our classes that Newton has discovered law of gravitation, but in fact it is in India, Brahmagupta. Okay, Brahmagupta is one of the famous astronomer in India who already anticipated long back before the Newton. Okay, so he already said that all the things are attracted toward the earth. Okay, so we have seen in our theory chapter that in 7th century Brahmagupta declared that all things gravitate to the earth in his book Brahma Supta Siddhanta. Okay, and if you see in the 15th century, that is 1687, at that time Sir Isaac Newton published his law of gravitation in his book Mathematical Principles of Natural Philosophy. In this book he has told everything about law of gravitation, but Sir Isaac Newton gave mathematical foundation for that. Okay, which is also known as Newton universal law of gravitation. And the universal law of gravitation says that F is equal to G into m1 into m2 by r square. This is very important formula for this particular chapter. Okay, this is going to be used throughout this chapter. That's why this law of gravitation is very important in all the physics related experiments. Okay, so remember that F is basically the force between the masses of mass m1 and m2, and the distance between mass m1 and m2 is r. So the force of attraction between these two masses is inversely proportional to the square of distance between them, and G is known as universal gravitation constant, which value is 6.67 into 10 power minus 11. Just remember, this is minus 11, not plus 11 Newton meter square per kg square. Okay, this is again a very important. Okay, so in the law of gravitation, you should remember the universal law of gravitation given by Sir Isaac Newton, and this formula you should remember, and I know all of you know all this formula. Okay, so the question is, who gave the theory of gravity? As I told you, it is Sir Isaac Newton. So don't confuse with option A, Charles Newton. So those who have given Charles Newton, you are wrong. It is Sir Isaac Newton. Okay, Isaac Newton, not Charles Newton. Okay, Charles Babbage, as you know, he is known as father of computer, whereas John Adam is something related to other field. Okay, so option C is the right answer. Let's see the next question. I am marking it as a very important questions. Discovery of universal gravitation constant G had done by whom? Okay, these are the four options. Okay, so let's see one by one. Antonio Laureate Lavoisier is known as father of chemistry, father of modern chemistry. He has not discovered this universal gravitation constant G. He is known as father of modern chemistry. Okay, and if you talk about Sir Isaac Newton, although he has given universal law of gravitation, but he has not found the value of the gravitation constant G. It is done by Henry Cavendish. Okay, Henry Cavendish has done an experiment which basically gives the exact value of the G. So the answer for this question is Henry Cavendish. Just remember, students generally confused with Isaac Newton. Okay, and we have seen the pointers related to universal gravitation constant G, that it is a universal constant, so it will be same for all the object, whether you are on Earth or Mars or anywhere in the universe, and it is independent. Okay, since it is a constant, it does not depend upon the temperature, shape or size of the body. And a very important, it is discovered by Henry Cavendish. It is in year 1798, and this was asked in many exams related to SSC and RRB. And basically how he found this basically G by an experiment called torsion balance experiment, and it is also known as weighing the earth experiment. Okay, some balance experiment he has made based on some angles. Okay, so this is also known as weighing the earth experiment, and he has found this particular value 6.67 into 10 power minus 11 Newton meter square per kg square. The value is again a very important for your exam, and sometime he can ask you about the dimensional formula. This is again a very important. You can derive this dimension formula. I am not going to discuss in today's session, but using this formula you can easily get the dimension formula of G. Okay, just put the mass, length and time unit and just get the value of this. So it is m-1, L3 and t-2. Okay, let's see the next question. If the distance between Earth and Sun were twice what it is now. Okay, so the distance between Earth and Sun, which is right now, it is twice than that. The gravitational force exerted between Earth by Sun would be what? Okay, so let's see the distance between these two planets, Earth and Sun. Okay, Sun is not a planet, it is a star. Okay, this is Earth, this is a Sun. So right now say the distance is r, but he is saying that the distance become twice. Okay, the distance become twice. So what would be the force, gravitational force exerted by Earth on the Sun? Okay, so you know the formula, F is equal to G into m1 into m2 divided by r square. Okay, so the distance become 2r. So if you in place of r you put 2r, so it become 2r whole square. So the force will become if you see in related to proportion, it become 2 square. Okay, it become 1 by 4 r square. Okay, so the gravitational force become 1/4 of what it is now. So option C, those who have given, they are right. So option C is the right answer. Okay, such type of question you can expect in your exam for the general science. Okay, that we have already seen these formulas, right? Let's see the next question. Which of the following statement is or are false? The value of G is same on its value on moon or earth. Yes, we know that it is a universal gravitation constant, so it is a constant, so it will be throughout same in the universe. So this is correct. The gravitational force between the center of two masses 2 kg placed at one distance meter apart is this one. So this one we need to calculate. I am just making it one question. Next is C. The force is inversely proportional to the square of distance between the two objects. Yes, it's again true. The force of gravity between the two objects doubles when the distance is half. Okay, the force of gravity between two objects doubles when it is half. So you know that F is inversely proportional to distance between them, it is r square. So what he is saying that the it got doubles when the distance is half. So when distance become half, it is 1 by 2. So it will become 1 by 2 square and it becomes 1 by 4 and it goes on the numerator. So force will be directly proportional to the 4 times. It will not be double, it will become 4 times. So this is incorrect. So let's see option. So which of the following is are not false? So C and D, this is incorrect. Option A only, this is again incorrect. Only D, yes, only D is the right answer because B, C, D are correct. So I am assuming this is true. So option D is the right answer. Okay, option C, only D is the right answer. Let's see the next question. The weight of human body is what? Maximum at pole, same at everywhere, maximum at equator, and more on the mountain than plain. Okay, so student, this is our earth. It is not a perfect sphere, it is oblate sphere. Okay, so it means this distance is smaller. Okay, and if you talk about this is larger. Okay, so you can use the formula. When distance is more, the gravity will be less. Okay, it is inversely proportional. So remember the weight of human body, indirectly he is telling about mg. Weight is what? It is basically force. Force is equal to mg. Okay, basically he is asking about the gravity, which basically depend upon the location. Okay, so location, if we are at the pole, basically the G will be maximum. Why it is maximum? Let's see. So we have seen that the difference between mass and weight is that mass is the amount of matter which is contained in the substance, whereas weight is force due to gravity. And mass remain constant everywhere, whether you are on earth or moon or anywhere, but it changes with the location. Okay, weight changes with the location. Since it is a force, the unit is Newton, and if you talk about mass, it is kilogram. Here G stand for gram, not gravity. It is a scalar quantity, is a vector quantity. Okay, and remember weight is 0 in space and mass is never 0, and weight is maximum at the pole and minimum at the equator. Okay, and we have seen in our theory classes that basically value of G is 9.8. okay, that we are using every day, but it is not correct. It depends upon the location on the earth where you are. Why? Because our earth is an oblate, as I told you. Earth, it is maximum at this point, and if you move downward, okay, it become decreases. So it is minimum at the equator and maximum at the pole. Again, if you go this, it will increase. So minimum at the equator and the maximum at the poles. Okay, let's see the next question. The weight of human being on the moon is 1/6 as compared to Earth. Okay, the moon does not have gravity like Earth. A very simple one. So option C, if you see, option A is true. Yes, A is true. We know that the weight of human being on the moon is 1/6 of the comparison to Earth. Okay, but the reason what he is telling that moon does not have gravity like Earth is not true. Okay, and if you see, you have to remember that this acceleration due to gravity on different planet, it is different. For example, here we have considered the acceleration due to gravity on the moon. So on the moon, the value of gravitational is 1.162. How it is derived? It is very simple. You know G, you know the mass of the moon, and you know the distance between the moon and the Earth. Basically, it is 1/4 of the radius, and Earth mass is 181. Okay, so if you substitute those value, you will get the gravity on moon is 1/6 of the gravity of the Earth. Okay, and comparing to the planets, since the Jupiter has the largest radius and the largest mass, okay, so its gravitational acceleration due to gravity, that is 24.8, which is maximum of all the planet, and the minimum is 3.7 for Mercury and the Mars. Okay, so instead of having two things, you should answer Mercury because it has the smallest radius and the smallest mass. Okay, so Mercury has the lowest acceleration due to gravity, whereas Jupiter has the largest acceleration due to gravity. Let's see the next question. If a feather, rubber ball and a wooden ball are falling free simultaneously from the same height in vacuum, this is very important. Now I'm marking it as important. Okay, so like if you have feather, rubber ball and wooden ball, you fall freely simultaneously at the same time from the same height in the vacuum, then the feather will reach first, the rubber will reach first, wooden ball will reach first, all of them will ground together first, and none of these are more than above. Student, before answering this question, I would like to show you one slide where we have discussed in the theory classes that it is free fall experiment. Okay, so before 1600, like before Galileo, basically people believe that heavier object will fall faster than lighter one. Okay, this is a common thing that we assume in our daily life. Heavier object will fall faster than the lighter one. So right now people also believe the same, but this is not the correct. So in 1600, the Galileo, basically he is the first person to conclude that the free fall does not depend upon the mass which you are carrying. Okay, and he demonstrated, like it was believed that he dropped 3 different masses of different object from the Leaning Tower of Pisa, and all 3 objects reach at the ground at the same time. Okay, but in 1987 Newton proved mathematically that if you see the acceleration due to gravity formula, that it is independent of mass. Okay, like mass which you are throwing, it is independent, or basically gravity is independent of that mass which you are throwing. Okay, so the value of G does not depend upon the mass of the falling object. That is very important. that you have to understand. Okay, so in this question, all of these three will reach at the ground at the same time. Let's see the next question. In the state of weightlessness, the size of candle flame will be, these are the four options. Okay, weightlessness means no weight at all. Okay, so the flame will be spherical because no forces are acting. Like in earth, if you have light a candle, so it is like this, it is basically due to the gravity. But if gravity is not there, basically this flame will become a sphere in shape. Okay, so option C is the right answer. Okay, so we have seen in theory class that free fall is basically the motion in which only gravity acts on it. Okay, and it is possible only in vacuum. Okay, and weightlessness is a condition body is in free fall and the apparent weight becomes zero even though gravity is acting on it. Okay, so all such pointer we have seen in our theory class. Let's see the next question. If a person sitting on a lift, when will he feel that his weight is increased? Okay, this is again the like the apparent weight. Okay, so remember, when lift is going up, weight will increase. It is in the same direction. It is when lift is going down, the weight will also come down. Okay, so the person sitting on the lift, when he feels that weight get increased, so the elevator is moving upward. So option A is the right answer. Okay, why his apparent weight become increased? So at ground we know that apparent weight or supportive weight is mg. At ground it will remain same, but if it is moving in up direction, because acceleration is also there, so it is added in the same direction, so the apparent weight will increase. Similarly, if it is moving down, okay, so the apparent weight will decrease because of the normal reaction which we known as supportive force is in the opposite direction. And in the free fall, gravity or acceleration becomes zero, apparent weight become zero. Sorry. If a person stands on the weight scale inside the lift and lift starting moving downwards, so as I told you, if you are going down, your weight will also decreases, so it will show the weight loss. Okay, so option B is the right answer.